I am now recording, just to let you know. Right, so ratio and proportion. Desmond, how would I say that?
6-4.
Okay, would anyone like to add to that, Ava?
No, I don't have that.
No? Done?
6-4.
6 to 4. Okay, so a lot of people would read that as 6 to 4. That's for reading. Right, what else can we say? Yep.
Okay, do that. So say you had a cake with 10 slices, someone could have eaten 6, another person 4.
Okay, so we are
Slices to 4.
sharing, or we are dividing. Okay?
The other ways
Shh.
you can write it is in a fraction, a decimal, and a percentage.
Yeah, so we can do fractions, decimals, percentages.
There's also like, use it for like making it. So for example, if you want to make something with water and flour, you could do 6 cups of water and 4 cups of flour.
Okay, so I will also put increasing amounts. Let's say if you are cooking. Right, just Jack.
You can rewrite it as 3 to 2, and there's an infinite
So we can
possibility of
simplify,
rewriting.
as well, or increase. Ava, what were you saying?
Oh, I said it.
Ian?
I'm not sure if this is right, but if you had the left one was smaller, like say it was 2 to 3, that could also be used in probability because you have 2 to 3.
Oh, right, okay, we'll have a look at that.
That's how my mom.
Yeah. Aidan?
So just to add on to Ian's probability thing, so you add the 6 and the 4, which gives you 10, then you can say there's a 6/10 chance that this happens in
Could it also be used in greater than, less than? Like the way it's set up, like 6. Well, yeah, and greater than 4. 6.
I guess it would help because one thing about ratio is it has a direction, doesn't it? It's 6 to 4, which would mean, we'll go back to what you were explaining. Charlie said about splitting up a cake. That would mean that if it was done in the ratio 6 to 4, one person will be getting 6 parts and one would be getting 4 parts. Okay? That meant the first person will always get more than the second person. And we have to do it that way. Okay, now let's just go through a few things just to check you understand that. Alright? The rewriting it as a fraction. So, I think you've already kind of said that this would then be 6 tenths. And this would be 4 tenths. Okay? And of course we know that fractions can be written, Liam. Should I express my displeasure at you? We already know that fractions can be written also as percentages, as decimals, so I won't necessarily go through that, you can do that. But just like fractions, they can be written as equivalent fractions, so that word equivalent comes in. So what is equivalent to 6 to 4? Well, we can write it as 3 to 2, because if I've got 6 pieces and you've got 4, then that just comes about that if I only had 3, you were only allowed 2. So what we are doing by the writing equivalent ratios is maintaining a proportion. And then we talk about cooking. So if I want to increase my overall amount but the cake still works, I've got to maintain the proportion. So I've got to do it like that. Okay? Yeah, so for instance, if I know I'm mixing, cake mix with sugar, okay, in the ratio 6:4, that might mean, well actually this is one bit we haven't mentioned yet. If I did 6 bags of cake mix and 4 spoons of sugar, is that correct?
No.
Why?
Well, actually,
So that would mean I would need 12 bags of mix and 8 spoons of sugar. Would that work?
no. Well, yes, actually, yes.
Yeah?
It would work, but the cake would taste horrible.
What do you mean? I didn't mean to say that.
Maybe the cake mix already has some sweetness in it.
Sugar is better.
Okay,
No, but it's not easy.
but we are maintaining a proportion, okay,
Yeah.
to keep everything the same. So what I was going to mention though is that kind of situation, fine. Normally though, there is another area where you might have seen ratios come up. Have you done kind of map reading and things?
Oh, yes,
Yeah,
like
it's-
scale.
Scales and something. Now, if I said to you, could you give me an example of a ratio in map reading?
It
Yeah.
can also be in photography, like pictures
yeah.
and stuff.
Okay, yeah. Yeah, all right. So in photography, have you got an example of a ratio in photography?
Yeah, like if this picture is like 600 pixels by 4 pixels, you can shrink that down to a ratio of 4 pixels by 600 pixels.
So 600 by 40,
Yeah.
or
So it would be 60 by 4.
so we could do it 60
Or
by 4.
6,000 by 4.
Or 6,000 by 400.
Yeah,
Can you just multiply it by 6?
or 6 by.
2.
That's the trick, wasn't it? People were going to say 6 by 2.
Oh, it's divided by 10.
Divide by 10, isn't it? Also, what would those units be, Cameron? So in this case, maybe pixels, okay? But 6 by 0.4 isn't.
Oh,
6
Bad quality.
not going to be very good quality, is it? Right, the one that I'm thinking of, have you ever done map scales where it's 1 to 25,000 or something?
1 square
Yeah.
is 25,000.
Oh, yeah.
Hang on, does everyone, there's one important thing about this with map scales. What does that mean, do you think, Owen? Which one's real life and which one's on the map? 50-50 chance. You get it? So the 1 is on the map, 25,000 is in
Real life.
real life. What are the units? Nash? Yeah, no, that's the correct answer. It's whatever you want. It'd be whatever you want.
It could be feet. It could
The reason is, this isn't important, this is kind of the last thing I'm going to talk about. Because in a map, what would I measure on the map? What units?
A distance.
But in what unit would I actually physically measure on a map?
Meters.
Centimetres? Millimetres, maybe. Okay? Really? I'm going to get my map out and go, oh yeah, I've just measured 2.5 kilometres on my map. That's a big ruler.
On the big map.
Big map. But, this is the thing, this is what's important. Guys, on the map, the thing with the ratio is the units should be the same and then we don't need to say the unit. So that map scale works. If I measure 1 millimetre on the map, in real life that would be,
No, that would be a really small amount. It'd be like 1 millimeter.
no, if I measured a distance of 1 millimetre on my map, in real life that would be, Caden?
1 meter. A kilometer.
25,000 millimetres.
But it depends on some scale.
No, it doesn't. 1 millimeter, if that was my scale, guys, that would be 25,000 millimeters in real life. If I were to measure on the map 1 centimeter in real life, I would actually be measuring 25,000 centimeters. And if I had a big map, 1 meter would be 25,000 meters. So, stop. So the thing about units, if I'm expressing a ratio, both sides of the ratio should be the same unit, and then I don't need to worry about units. Okay? So if I am talking about a mixture, a cake mixture, okay? If I do it a mixture of 4:1, cake, flour and water, then I might be struggling there. But what would I do? No, 4:1. How would I measure that? Cups. Anyone done the cooking? American system especially. 4 cups of flour. You can get it actually measured out. You can get 4 cups of flour, 4 cups or 1 cup of water. Mix it together. Or 4 bowls of flour for 1 bowl of water. What?
You said 4 then 1. 41.
Well, I said 4:1 ratio. Okay.